Alright, this is just a quick video to introduce section 12.6, which is solving by completing the square. Alright, so this comes from our concept of solving using square roots that we have already seen. Okay, so this is similar to problems like this. So 4x squared plus 10 equals 46. So we've seen these kinds of questions already. We solve these, we subtract 10, we get 4x squared equals 36. Divide by 4, we get x squared equals 9. We take the square root of both sides, and we get x equals positive or negative 3. Okay, so that's kind of the first step of these types of problems that we're looking at here. All right, the next thing to look at is then this also can apply to problems like this, where we have x squared plus 4x plus 4 equals 25. Okay, so again, we know this isn't in standard form because we got that number on the right hand side there. But I'm still going to look at this left, and I'm going to see if I can factor the left. And what the left factors into is x plus 2 times x plus 2. So same thing in both sets of parentheses. So that is x plus 2 squared equals 25. Well, this is the same thing as having just that variable squared like we did on the other side. So again, I can take the square root here of both sides. This then becomes x plus 2. Square root of 25 is 5, so we have positive or negative 5. So the two pieces that we have here now are x plus 2 equals 5 and x plus 2 equals negative 5. Then I can solve both of these. Subtract 2 on my first one, x equals 3. Subtract 2 on my second one, and x equals negative 7. Alright, so we can also make any trinomial a perfect square. So let's say we have x squared minus 12x. And I want to know, okay, what do I need to add onto this to be able to make this a perfect square, to factor this as a perfect square? And the way we find this is we take our b value here. Okay, we take b, in this case negative 12, we divide it by 2, and then we square it. So negative 12 divided by 2 is negative 6 squared equals 36. So that is what I'm going to add here. So now we have x squared minus 12x plus 36, and that can be factored into x minus 6 times x minus 6. And we can do this with any trinomial. We can find that term that we need to add to be able to complete that square, to write it as some binomial squared. Alright, so here's how we're going to use this to solve quadratics. And this can be used to solve any quadratic. So let's say we have the problem 3x squared minus 12x plus 6 equals 0. Okay. Well, first thing I'm going to do on a problem like this is I'm going to look and I'm going to see I have a greatest common factor. And in this case, that greatest common factor is 3. So I'm going to divide each of these terms by the greatest common factor. Okay? Same thing to everything. Right? As long as I do the same thing to everything, I'm keeping it balanced. X squared minus 4x plus 2 equals 0. Okay? All right. Now on the left, this cannot be factored into a perfect square. I cannot factor this into x minus something squared. Okay? It's not possible yet. So what I'm going to do So I'm going to take this trinomial, and I'm going to move my c, my positive 2, to the right. So this has become x squared minus 4x equals negative 2. Now, I'm going to take my b, and I'm going to do that process that I did on the one before. Negative 4 divided by 2 squared. Okay, so b divided by 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. Now, here's the key. I added positive 4 to the left side of my equal sign. It is now unbalanced. I need to also add 4 to the right side so that my equation will be balanced. Now, I can take the left side. It is x minus 2 times x minus 2 equals negative 2 plus 4 is positive 2. Left becomes x minus 2 squared equals 2. We will take the square root of both sides. That becomes x minus 2 equals positive or negative the square root of 2. Okay, I can't simplify that. So to just get x by itself, what I will do is add 2 to both sides, which gives me x equals 2 plus or minus the square root of 2. And that's my final answer. All right, this is just an intro here. We will do more practice on this in class.